Hello, I've had a question in lesson 6, question 46, as to how one would go about doing this particular question. So we have a rescue worker sliding a box of supplies down from rest down a hill to campers that are trapped. So we're looking at a situation like this. So the box is just being released to slide down the hill on its own. It's at an incline of 25 degrees. And the slope itself is 200 meters in length. Coefficient of kinetic friction, UK, is 0.45. And A part wants to know what's the acceleration of the box as it goes down the hill. So A part I'll do down here. So I need a free body diagram. So the driving force, what's pulling this box down the hill, is the force due to gravity, FGX. So we have force due to gravity, but it's the component FGX that's sliding it down the hill. We have our normal force, which is perpendicular to the slope, and it's equal and opposite to FGY. And then we have force due to friction opposing the motion. So we start with our formula of unbalanced force, Fu ma, and we're interested in the forces along the slope. So these two forces are going to constitute the unbalanced force. So we have FGX, the driving force, minus force due to friction, the opposing force, and that will make up our unbalanced force when you take the difference between those two. So, moving along, FGX, that is mass times gravity, and we're on a slope, so it is sine theta, minus friction is mu Fn, and Fn, I'll just do it over here, remember, our normal, oops, not that, we want force due to friction. Force due to friction is equal to mu Fn, and in this case, Fn is Fgy, and Fgy is mass times gravity cos theta. And in the note, I talked about the geometry on why it's sine and cos for those particular components. Okay, so mu mg cos theta equals ma. We see that each term has a mass, so mass does not play a role in this. So that means our acceleration is isolated. That's what we're looking for here. So doing our substitution, 10 sine 25 minus 0.45 10 cos 25. And if we plug that into our calculator, we can get the acceleration down a slope. So 10 sine 25 minus 0.45 times 10 cos 25. And I get 0.15 meters per second squared down the slope. So there's your acceleration of the box with acceleration included. So there's our A part. B, at what speed does it reach at the bottom of the hill? So B part, we're now looking for V2. That is our desired piece of information. It said it was released from rest, so we know that's 0 meters per second. We just calculated the acceleration. So acceleration is 0.15 meters per second squared down the slope. And our delta D is given information. It was a 200-meter slope. So looking at the given information, we're going to have to use V2 squared equals V1 squared plus 2AD. Doing our substitution. Our unknown is already isolated. V1 was 0, 2 times 0.15 times 200. Don't forget, I'm going to do the square root in one step here, so I'm going to do 2 times 0.15 times the 200, and then I'm going to take the square root of that. I get about 7.75 meters per second down the slope. All right. What do we got left? C. How long does it take the box to reach the bottom of the hill? So now we're just playing with, we have all our information. So C part, I've got a ton of information from above. T is my unknown. So I think I'm just going to go with V2 equals V1 plus AT. So V2 is 7.75 equals V1 is 0 plus 0.15 T. Isolating and divide that by 0.15, we get approximately 51.6 seconds. So very slow slide. All right. So there's how you would approach this particular question. I'm thinking that the first part, setting up your free body diagram, was the challenge in itself, and making sure your signs and coasts are proper and in the right direction. It's tricky because traditionally we know that for a vector, if it's on a flat surface and you have a force applied to it, so FA, your FAX is equal to the magnitude of FA cos theta, and your FAY is equal to the magnitude of F sine theta. So you'll notice that these particular angles are backwards here for what some people feel that they're backwards for your FGX and FGY. So just be careful and mindful of your sines and your coses. At the end of the day, if you were to get your sines and your coses mixed up down here, if you got these backwards, it's not detriment. It's not a huge detriment to the overall mark in the question because your process is right. I'm looking for your free body diagram. Was it set up properly? Okay, you mixed up your sines and your coses. Big deal. The process overall was done very, very well. All right, so keep that in mind. Normally what would happen is if you did switch these two, this answer would come out to be a negative, or could potentially come out to be a negative, and have the object sliding up the hill. At that point in time, that's a tip-off as to what happened. You switched up your cos and your sine. But other than that, if you have any other questions with that or follow-up, let me know, and I'll try to clarify.